Hey everybody, today we're talking about percent yield, and after this we only have one more section until the unit test. So this one is actually not a new thing in terms of stoichiometry, but kind of a side equation that we do at the end of stoichiometry. So for instance, let's say right here I'm doing a reaction of chlorine and iron. It's a really cool reaction. You can't hear it, but if you want to watch it, you can. And basically we're going to take chlorine gas and iron and put it in there. Okay, they're going to put it in. Oh, it's really cool. Ready? Here goes. So those are red fumes of iron chloride. Kind of cool. So basically, when we do reactions, we start with reactants and we expect all this product to be made, and that's not necessarily the case. You won't get 100% of your reactants turning into product. So for instance, if we take some solid iron and we react it with chlorine gas, we're going to create iron 2 chloride. Okay, so let's say you start with 5 grams of iron. How much would you expect to be produced? Okay, so you would translate the problem, and then you would balance it, right? You guys are good at balancing by now. And then you would say, okay, well, if I have 5 grams of iron, how many grams of FeCl3 would I make? And you'd set up the stoichiometry, and you put the molar mass of iron right here, and you'd say it's a 2-to-2 ratio, and you'd do a little side hustle to get the molar mass of iron chloride, and you'd say, hey, I expect there to be 14.5 grams of iron chloride. Now this right here, this is a theoretical yield. This is a hypothetical. This is how much you would expect to get. But that's not always the case. In experiments, we do not always get that 100%. Okay, so sometimes you get less. Sometimes this has to do with equilibriums, which we're not really going to touch on, unfortunately, this year. Sometimes it has to do with errors. Sometimes it has to do with like the fact that you are taking chemicals from one container into another, and not all of it transfers. Okay. So for the sake of this problem, let's say that you've calculated that you should get your theoretical yield is 14.5 grams, but you only get 9.2 grams at the end. So what percentage did you get? All right. What is your percent yield? And that's what we're going to be talking about. So here's some things that you need to know. The theoretical yield, this right here is what you predicted. What you predicted, aka calculated from doing stoichiometry, where you assume that 100% of the reactants turn into products. And the experimental is the actual, or what you got in the experiment in real life. Okay, and I have to give you some of these numbers in the problem. And to do the problem, to do the equation, it's the percent yield is equal to the experimental divided by the theoretical, and that's a decimal, and then I multiply it by 100 just to put it into percentages. Okay, so for this one right here, it would be 9.2 divided by 14.5, and I would get 63%. So that's actually the first one right here. It's 9.2 grams, and this one right here would be 14.5 grams. And when you take these and you divide them and multiply by 100, you'd get 63%. Cool? Cool. All right, so now let's look at an example that might have a little bit more algebra involved, okay? And to do this one right here, we are going to say, actually, sorry, before I say that, that means I got 63% of what I was expecting. So that's what the percent yield is. But let's go ahead and do this next one. Let's say you were expecting to get 24.5 grams of a product, but you got a 78% yield. How much was the experiment? So how much was the experimental yield? So you can kind of work backwards and stuff like that, and you can use variables. So if you're expecting to get this, okay, expecting. Now expecting and experimental sound the same, but they're not. Expecting means theoretical. Okay, so I'm going to put 24.5 grams down here, and I ended up with 78%. Okay, so the first thing I'm going to do is I'm going to divide both sides by 100%. So I divide this side by 100% and I divide this side by 100%. I get 0.78, and all I'm left with over here, I'm going to put an x here, is x divided by 24.5. Then the last thing I'm going to do is I'm going to multiply both sides by 24.5. So 24.5 times 0.78, and I get 19.11. And that right there is my experimental yield, what I actually got in the experiment. So if you were to kind of like rearrange this, if you started with 19.11 grams and put it into the experimental, and your theoretical is 24.5, you get 78. Okay, cool. So now we can do one more big problem, and this big problem, we'll do it right here. And basically it revolves kind of around this very first one that I did right here. Okay, and I'm going to skip a couple steps because you all are experts at stoichiometry by this point. But basically, if I take 5.0 grams and I get it, what's going to happen? Well, okay, so I had 2 here, I had a 3 here, I had a 2 here. And if I started with 5 grams of Fe, I want to know how many grams of FeCl3 actually formed, or sorry, theoretically formed, so that I can compare it to the other ones. Okay? So it'll look like that. So cool. All right. So 5 grams of Fe. And I want to know how many grams of FeCl3 I should expect at least. Okay, so this one right here, I'm grams of Fe, and you can actually copy it straight from here if you want. Grams of Fe and moles of Fe. I'm gonna go moles of Fe down here and get into moles of FeCl3 right here. And then I'm gonna say moles of FeCl3 and grams of FeCl3, kind of like that. Cool, cool. So now I can start to fill it in. My molar mass of iron just by itself is 55.85. My moles of iron is 1. It's a 2-to-2 ratio. And my little side hustle I'd have to do on the side is 162.2 grams for every 1 mole. And when you calculate this all out, 5 times 1 times 2 times 162.2, then divided by 55.85, divided by 2, I get 14.5 grams, 14.5 grams of FeCl3. That right there is my theoretical yield. That's what I should get if 100% of everything worked out perfectly, right? This space right here is just to do my side hustle that I did over here, but we already kind of did it. So this right here is my theoretical, but what I only got, the problem gets you, I only got 12.4. So if I only got 12.4 grams of this, I go 12.4 divided by 14.5. And then to turn that decimal into a percentage, I multiply it 100, I get 85.5%. And that is how you do it, my friends.